Okay, year 11. So we've got the right angle triangle, and you know of the three trig ratios, sine, cos, tan. Well, in fact, there's actually 6 of them. You've got tan, short for tangent, sine for sine, cos for cosine, but you've also got cot for cotangent, cosec for cosecant, and sec for secant. These 3 are relatively straightforward, because as long as you know these 3, you'll know these 3. Tan is equal to, if I go off the angle A as I've put in here, tan is equal to the opposite over the adjacent, so A over C in terms of the triangle I've drawn here. The sine is equal to the opposite over the hypotenuse, so A over B, and the cosine is equal to the adjacent over the hypotenuse. Well, cot is actually the same as 1 over the tan of A. So that means the reciprocal of tan, which is C over A. The cosecant is equal to the reciprocal of sine, so 1 over sine, and the reciprocal of sine is B over A. And finally, the 6th one, the sec of A, is the reciprocal of cos, and the reciprocal of cos would be B over C in this case. Now, why we need these 3 becomes more apparent as you get through the A level, more so in the year 13 than the year 12, but it's good to learn them now. So first example, we know from the GCSE maths how to find sine, cos and tan. So we'll start with the tan of theta. We use the Greek letters mainly in A-level mathematics, but you're probably used to them in GCSE anyway. So the tan of theta is the opposite over the adjacent, so that one would be 15 over 8. The sine of theta is the opposite over the hypotenuse, so that would be 15 over 17. And the cosine of theta is the adjacent over the hypotenuse, so that would be 8 over 17. So as I've just pointed out, these 3, cot is the reciprocal of tan, so that would be 8 over 15. Cosec is the reciprocal of sine, so that would be 17 over 15. And finally, sec is the reciprocal of cos, so that would be 17 over 8. And there is your 6 trig ratios for that right angle triangle. So in order to answer this one, we can start with a right angle triangle and labelling one of the angles A, and we know that tan is opposite over adjacent. The opposite I take to be 3, the adjacent side I take to be 4. Using Pythagoras' theorem or otherwise, 3 squared plus 4 squared is 25, square root, that's 5. Hence, we can answer the questions using the knowledge of sine, cos, tan. Now, as I mentioned in a previous example, sec comes from cos. Now, the cos of A is equal to adjacent over hypotenuse, so therefore sec A is the reciprocal. Now, cot and cosec come from the other 2, so we've got sine is 3 over 5, opposite over hypotenuse, and tan is opposite over adjacent, which is already in the question anyway. So cot is that one reciprocal. Cosec is the reciprocal of sine. And 4 over 3 take 5 over 3 is minus 1 over 3. Now the exact trig ratios for 30, 60, 45 you should already know from your GCSE. However, this triangle here allows you to work them out for 45 degrees. So the tan of 45 degrees is opposite over adjacent 1 over 1, which is 1. The sine of 45 degrees is opposite over hypotenuse, so that's 1 over square root of 2. Likewise, cos of 45 is adjacent over hypotenuse, it's the same, 1 over square root of 2. And just like with GCSE, you're expected to know those off by heart. And the same is true for the 60 and the 30 degree, which we can get from the equilateral triangle with 2, 2, 2. Dropping a perpendicular, we create a side of 1, side of 2, and by Pythagoras' theorem, square root of 3. Again, you should have seen this before anyway. So the tan is equal to opposite over adjacent, so that's the square root of 3. Sine of 60 is opposite over the hypotenuse, so that's the square root of 3 over 2. And the cos of 60 is 1 over 2, a half. Using the same triangle, we can do the same for the 30 degree, because the 60 degree, which was up there, is now 30 and 30. So tan is opposite over adjacent, so 1 over the square root of 3. The sine of 30 is opposite over hypotenuse, so 1 over 2. And the cos of 30 is adjacent over hypotenuse, so the square root of 3 divided by 2. So let's put this into practice. To find the value of p using the sine rule, p divided by the sine of 65 should be the same as 7 divided by the sine of 40. So p is equal to the fraction I've just said, and if I take that across the other side, it becomes a times sine of 65. All that's required now is for us to put that into the calculator. So we got 7 divided by the sine of 40 times by the sine of 65 equals, and to two decimal places we get 10.15. Now in this question we require the angle, so it's easier to write the sine rule upside down. And whilst I want to find that angle, I actually don't know the side opposite the angle. So actually I have to start by finding this angle down here first, because sine A, that angle goes with that side, 5.6, as that angle goes with that side, 7.8. Exactly the same structure as the previous example. Take this across the other side, so I have the fraction that I've already got. That becomes times, and I need to put that into the calculator. So we have the sine of 70 divided by 7.8 times by 5.6 equals, and we get 0.67. Now to find the angle, we then need to press shift sign of that number, and out comes 42.4 degrees.